Hello students, in the last video we discussed what differentiation means on a graph. So we discussed what is the meaning of delta y by delta x, average rate of change in y with respect to x. Also we discussed the meaning of dy by dx on a graph. So dy by dx is rate of change in y with respect to x or change in y per unit change in x at a given value of x. We know, so dy by dx is slope of the graph at a given value of x. That's what we studied in the last video. We also studied the qualitative behavior of different graphs. We drew different graphs and we tried to understand what is the information that the graph is conveying to us. So from the shape of the graph, we try to understand if y increases as x increases or y decreases as x decreases. We try to understand if y is increasing, is it increasing at a constant rate or increasing rate or decreasing rate, right? Similarly, if y is decreasing, is y decreasing at a constant rate, increasing rate or decreasing rate? Okay, what happens when y becomes maximum? And what happens when y becomes minimum? So these are the things that we discussed in the last video. Now in this class, I am going to discuss how to find maximum and minimum values of y in a function. When a function is given to us, how do we find the maximum value of y? Or how do we find the value of x where y becomes maximum? Similarly, the value of x where y becomes minimum. That's what we are going to discuss now. Let's take any function. In this case, when we say y is a function of x, it means y depends on x. When y depends on x, y may increase as x increases and becomes maximum and then decreases. It's possible. So this case is possible. Y starts increasing as x increases and y becomes maximum at a particular value of x, and then y decreases as x increases. Okay, so there are functions where y becomes maximum at a particular value of x. There are functions where y becomes minimum at a particular value of x. There are functions where both y becomes maximum and also minimum. At one particular value of x, y becomes maximum. At some other value, y becomes minimum. There are varieties of ways in which y depends on x. Okay, so there are functions y changes monotonically. It means y increases continuously as x increases. So that's also possible. In that case, maxima or minima does not exist. Y does not become maximum at any finite value of x, nor y becomes minimum at any finite value of x. So we say that is monotonic behavior. For example, y continues to increase as x increases. At no finite value of x, y becomes maximum or minimum. Okay, this behavior also does exist. It doesn't have to be a straight line graph. Okay, look at this graph. Y increases as x increases continuously. Nowhere y becomes maximum or minimum. Such behavior also exists. So we are going to discuss for what value of x y becomes maximum or minimum, if at all maxima or minima exists. If maximum exists, if y becomes maximum at finite value of x, at what finite value of x y becomes maximum? And similarly, at what finite value of x y becomes minimum? That's what we are going to discuss. So when a function is given to us, let's understand what happens to y when y becomes maximum. when y becomes maximum, what happens to the slope of the graph? We discussed already. Let's look at it again. So let's draw some arbitrary shaped graph, assuming that maximum and minimum both exist. Okay, so I'm drawing this graph, assuming y becomes maximum, say at x is equal to x1, and y becomes minimum at x is equal to x2. Now, at maximum value of y, the slope is 0. As I discussed in the last video, what is happening here? As x increases, y is increasing. Y becomes maximum. So in this part of the graph, y increases. In this part of the graph, y decreases. And here again, y increases. So here, y increases becomes maximum and then decreases becomes minimum. At maximum value of y or at minimum value of y, the graph is flat. What do I mean by the graph is flat? The slope is 0. Here, if you imagine this to be a hill that you are climbing up, when you reach the top of the hill, this part of the graph, this part of the hill is flat. The slope is 0. Similarly, in a valley, this part of the valley is flat. So take a small interval around the minimum value of y, or take a small interval around the maximum value of y. In that small interval, the slope is 0. Or if you draw a tangent at maximum value of y, if you draw a tangent to the graph at maximum value of y and draw a tangent at minimum value of y, these tangents are parallel to x-axis. It means angle made by the tangent drawn at maximum value of y and at minimum value of y with x-axis. Angle made by the tangent drawn at maximum value of y and at minimum value of y with x-axis is 0. It means tan theta is equal to 0. It means slope or dy by dx is equal to 0. Slope or dy by dx becomes equal to 0 at maximum value of y or at minimum value of y in both places. This is one condition. So we can say that the first condition is when y becomes maximum or minimum, dy by dx becomes equal to 0. Now, this is the slope at the maximum or minimum. Now look at the change in the slope. Slope is 0 for a moment. Slope is not constant at 0. Slope is 0 for a moment here. Slope continues to change. Slope is changing. Slope is not a constant. Dy by dx is changing. Dy by dx is not a constant. During the process of the change in dy by dx, dy by dx becomes 0 at that particular value of x. Okay, so dy by dx becomes 0 only for a moment. Since dy by dx is changing, so next thing that we are going to look at is change in the slope or change in dy by dx. That's what we are going to look at. Look at the slope around the maximum value of y. Around the maximum value of y, let me call this point A. Look at the slope around A. Take a small interval around A. On the left side of A, slope is positive, and on the right side of A, slope is negative. Slope is positive and decreasing to become 0 at A. Slope is negative and increasing in magnitude. Increasing in magnitude means slope is decreasing. Look, here slope is 0, maybe here slope is -1, maybe here slope is -2. It means what? Slope is decreasing. On the right side of A, slope is decreasing, or the modulus of slope, the magnitude of slope is increasing. So on the left side of A, slope is decreasing, and on the right side of A also slope is decreasing. It means around the maximum, if you take a small interval around the maximum value of y, if you take a small interval around x is equal to x1, in that small interval around x is equal to x1, the change in slope is negative because slope decreases. So here the conclusion that we have come to is that at y maximum, or in an infinitesimally small interval constructed around y maximum, slope decreases. Okay, at y maximum, I would say rate of change in slope is negative. We are not talking about rate of change in y. Rate of change in y is 0. That's what slope is. So slope is equal to 0 at that moment, but rate of change in slope is negative because slope is positive, decreases to 0 and becomes negative. So rate of change in slope is negative. In other words, I can say rate of change in dy by dx. What is slope? Dy by dx. Rate of change in dy by dx with respect to x is negative. What it means is, as x increases, dy by dx decreases. Rate of change in dy by dx. So rate of change in dy by dx means this is what rate of change in dy by dx means. A small change in dy by dx divided by a small change in x. Rate of change in y is a small change in y divided by small change in x. Similarly, rate of change in dy by dx means a small change in dy by dx divided by small change in x. Okay, when change in x is positive, change in slope, that is change in dy by dx, is negative. Okay, so we call this second derivative of y with respect to x. We denote this as d square y by dx square, d2y by dx2, or d square y by dx square. Okay, so this is derivative of slope, derivative of dy by dx. Dy by dx is derivative of y, and this is derivative of dy by dx, or we call it second derivative of y with respect to x. So second derivative of y with respect to x is what? Negative. Where? When y becomes maximum. So the condition for y maximum is slope is 0 and rate of change in slope is negative. The first derivative is 0 and the second derivative is negative. So that's when we say y becomes maximum. So I'm going to write down in the next page, at x is equal to x1, at x is equal to x1, dy by dx is equal to 0 and d square y by dx square, that is second derivative of y with respect to x, or derivative of dy by dx with respect to x, or derivative of slope with respect to x, is negative. Okay, so that's when we say y is maximum. At x is equal to x1, y is maximum. So these are the two conditions for y to be maximum at x is equal to x1. Look at the graph again. Let's see what is happening around the minimum. Let's call this minimum point on the graph as B. And you know, at B, if you draw a tangent, the tangent is parallel to x-axis, means slope at B is equal to 0. Slope is 0 at minimum also. Look at the slope around B. Take a small interval, take an infinitesimally small interval around point B. In that infinitesimally small interval, you can see that slope increases from a negative value to 0 and increases from 0 to a positive value. In a small interval around point B, slope is negative on the left side of B. You can see that slope is negative on the left side of B. Slope is positive on the right side of B. So why is slope negative? Y decreases as x increases. That is why dy by dx is negative on the left side of B. And on the right side of B, y increases as x increases. So slope is positive. So slope increases from a negative value to 0 and 0 to a positive value in that small interval constructed around point B. That means around point B, change in slope is positive. Slope increases, right? Since slope increases around point B, that is at y minima, change in slope is positive. At y minima, rate of change in slope is positive. Rate of change in slope is positive means change in dy by dx divided by change in x is positive. So rate of change in slope is positive means d of dy by dx divided by dx is positive. Okay. It means second derivative of y with respect to x is positive. So that's the condition for y minimum. So I'll write down in the next page. At x is equal to x2, slope is 0 and rate of change in slope, that is second derivative of y with respect to x, is positive. At x is equal to x2, slope is 0 and rate of change in slope is positive. So at x is equal to x2, y is minimum. So these are the two conditions for y becoming maximum and becoming minimum at a particular value of x. Okay, let's see some examples here. Let's look at the first example. Let's look at some functions. Y is equal to x square minus 4x plus 7. Let's look at at what value of x y becomes maximum, or at what value of x y becomes minimum. These maxima minima are called turning points on the graph. Technically speaking, these points are called inflection points. Maxima and minima are called inflection points or turning points. I would simply call them turning points because until then y increases, after that y decreases. Okay, look at maxima. Until then y increases, after that y decreases. So the graph has taken a turn. Similarly, at B, until then y decreases and after that y increases. So graph has taken a turn. Okay, so that is why I would call them turning points, but technically they are called inflection points. Okay, now let's look at if turning points exist in the case of this function. Okay, we are not drawing the graph. We don't know how to draw the graph yet. I will discuss how to draw graphs without actually putting data points on the graph. Just by understanding the qualitative behavior, I will discuss how to draw graphs. So we are not going to draw the graphs here for this function, but we are going to find out at what value of x, y becomes maximum, or at what value of x, y becomes minimum. For that, what we need to do is, we need to verify the first condition. What is the first condition? At y maximum, slope becomes 0. At y minimum also, slope becomes 0. So first find out the derivative of y with respect to x. Check at what value of x dy by dx becomes 0 for the given function. This is the given function. So we are going to find out dy by dx, and we are going to check at what value of x dy by dx becomes 0. This is dy by dx. You know how to differentiate. When we differentiate this function, we are getting 2x minus 4. So dy by dx is equal to 2x minus 4. So at what value of x dy by dx becomes 0? That's what we are trying to find out. Dy by dx 0 means 2x minus 4 is equal to 0, or x is equal to 2. So at x is equal to 2, dy by dx becomes equal to 0. It means at x is equal to 2, y is either maximum or minimum. But which is it? At x is equal to 2, y is either maximum or minimum. So which is it? Is it maximum or minimum? To find that out, we will do the second derivative. We will find out the rate of change in slope. That's what we are going to find out. If rate of change in slope is positive, y becomes minimum at x is equal to 2. If rate of change in is negative, it means y becomes maximum at x is equal to 2. Well, if you don't want to do differentiation, take x is equal to 1.9, find out y. Take x is equal to 2.1, find out y. Take x is equal to 2, find out y. If y at 1.9 is less than y at x is equal to 2, and also at 2.1 if it is less than y value at x is equal to 2, it means y becomes maximum at x is equal to 2. It becomes cumbersome, multiplications, right? Putting the values and finding the value of y, putting the values of x here and finding the values of y is difficult. Finding the second derivative is easy. So what we are going to do is, we are going to find out the rate of change in dy by dx, the rate of change in slope. We know dy by dx is equal to 2x minus 4. So we are going to find out the rate of change of this fellow, d 2x minus 4 by dx. This is what we are going to find out. So when you simplify, you are getting positive. So second derivative is positive. At x is equal to 2, dy by dx is equal to 0, and d square y by dx square is positive. So what is the conclusion we can come to? It means at x is equal to 2, y becomes minimum. At x is equal to 2, y is minimum. If you substitute x is equal to 2 here, you will get the minimum value of y. Okay, so y minimum. You know y is equal to what? X square minus 4x plus 7. Substitute x is equal to 2 for the minimum value of y, because we know y is minimum at x is equal to 2. So y minimum is equal to 2 square minus 4 into 2 plus 7. So 4 minus 8 plus 7, which is equal to 3. So the minimum value of y is equal to 3. It doesn't go below 3. Y does not go below 3. Right? Let's look at one more function. I'll give you one more example. Take y is equal to 3x minus x square. The second example that I'm going to discuss. Y is equal to 3x minus x square. Let's see what happens to y. I mean, where is y maximum or minimum? For that, the first derivative we need to find out. We need to check if the slope becomes 0 at any point. If the slope becomes 0 at any point, at that point y may be maximum or minimum. So first we need to find out the slope or dy by dx. So differentiate this d3x minus x square by dx. We got dy by dx is equal to 3 minus 2x. So dy by dx is equal to 0 at x is equal to 3 by 2. We can see that. At x is equal to 3 by 2, dy by dx becomes 0. It means at x is equal to 3 by 2, graph takes a turn. X is equal to 3 by 2 is a turning point. But which turning point is it? For that, we need to find the second derivative also. So we need to find out rate of change in slope also. We are going to find out rate of change in slope here. We got the slope 3 minus 2x. So rate of change in slope is minus 2. It means rate of change in slope is negative. It means slope decreases. Slope decreases means y becomes maximum. So at x is equal to 3 by 2, we come to the conclusion that y is maximum. Substitute x is equal to 3 by 2 here, you will get maximum value of y. Substitute x is equal to 3 by 2 in the given function. You will get maximum value of y, which is this. You can simplify it further yourself. I'll give you one more example. Take this, y is equal to 4x plus 1 by x. Y is equal to 4x plus 1 by x. Let's find out if maxima or minima exist. It means if dy by dx becomes equal to 0 at any particular value of x. So let's find dy by dx. If you find dy by dx, you'll get 4 minus 2 by x square, 1 by x square. All right. So 4 minus 1 by x square is equal to 0 at what value of x? 4 is equal to 1 by x square, or x square is equal to 1 by 4, x is equal to plus or minus 1 by 2. So there are two values of x where the slope becomes 0. At x is equal to minus 1 by 2, slope is 0, I mean dy by dx is 0. So the graph takes it on at x is equal to minus 1 by 2. Graph also takes it on at x is equal to plus 1 by 2. Because at x is equal to plus 1 by 2 also slope is equal to 0. Okay, so let's find out the second derivative. So at x is equal to minus 1 by 2, there is one turning point. At x is equal to plus half, at x is equal to plus 1 by 2, there is one more turning point. Okay, but which turning points are there? That's what we are going to find out. For that, we need to find the rate of change in dy by dx, or the rate of change in slope. We got a dy by dx here, substitute it here. You will get 4 is a constant. When you find the derivative of 4, you will get 0. So it is dy by dx of minus 1 by x square, or minus d of x power minus 2 by dx, or this is 2 x power minus 2 minus 1. So this is 2 by x cube. D square y by dx square is 2 by x cube. Look at the second derivative. At x is equal to minus 1 by 2. What is happening? Substitute x is equal to minus 1 by 2 here. Because at x is equal to minus 1 by 2, there is one turning point. At x is equal to plus 1 by 2, there is one more turning point. So substitute both of them in the second derivative and find out at which value of x the second derivative is positive and negative. Okay, so at x is equal to minus 1 by 2, you are getting the second derivative negative. X cube is negative. It means at x is equal to minus 1 by 2, is y maximum or minimum? Slope is 0, I mean dy by dx is 0, d square y by dx square is negative. Slope is 0, but rate of change in slope is negative. It means slope decreases. Slope decreases means y is maximum. At x is equal to minus 1 by 2, y is maximum. Similarly, at x is equal to plus 1 by 2, you will get d square y by dx square positive. It means change in slope is positive. It means slope increases around this value. This value. It means y is minimum. So at x is equal to plus 1 by 2, y is minimum. Substitute x is equal to minus 1 by 2. You will get maximum value of y. Substitute x is equal to plus 1 by 2. You will get minimum value of y. So for this function, we have two turning points. One turning point it is at x is equal to minus 1 by 2. The other turning point is at x is equal to plus 1 by 2. Let's look at one more example. Y is equal to x cubed by 3 minus 2x square plus 3x plus 1. Let's look at this example. Here, let's find out where dy by dx becomes equal to 0. For that, let's find out dy by dx first of all. Differentiate this, you will get x square minus 4x plus 3. So at what values of x dy by dx is equal to 0? That's what we are trying to find out. It means x square minus 4x plus 3 is equal to 0 at what values of x? So factorize and simplify. This is x square minus 3x minus x plus 3. So we can understand that dy by dx is equal to 0 at two values of x. When x is equal to 1, dy by dx is equal to 0. When x is equal to 3, also dy by dx is equal to 0. That means there are two turning points here, two inflection points here. Which inflection point is x is equal to 1? Is it maximum or minimum? Which inflection point is x is equal to 3? Is it maximum or minimum? Let's find out. For that, we need to find the second derivative, or the rate of change in dy by dx. Rate of change in slope. That is dx square minus 4x plus 3 by dx. So this is dy by dx. We'll put it here. When you simplify, you will get 2x minus 4. This is the second derivative. At x is equal to 1, is the second derivative positive or negative? Let's find out. We are getting second derivative negative. At x is equal to 3, look at these two turning points. One turning point is x is equal to 1. At x is equal to 1, the rate of change in slope is negative. And at x is equal to 3, substitute x is equal to 3, you will get rate of change in dy by dx positive. It means x is equal to 1 is maximum. I mean, at x is equal to 1, y is maximum. At x is equal to 3, y is minimum. At x is equal to 1, y is maximum. And at x is equal to 3, y is minimum. That's the conclusion we come. Substitute x is equal to 1, you'll get maximum value of y. Substitute x is equal to 3, you'll get minimum value of y. Let's look at one more example. Y is equal to ax cube plus bx plus c. This is the example that we are going to discuss now. Let's find dy by dx. If you find dy by dx, you will get a, b and c are constants. Okay, some numbers. So this is 3ax square plus b. So where does dy by dx become equal to 0? 3ax square plus b is equal to 0. Or x square is equal to minus b by 3a. X is equal to square root of minus b by 3a. That does not exist. It's an imaginary number. It means nowhere y becomes maximum or minimum. So there is no turning point in the graph. It's a monotonic graph. Since there is no turning point in the graph, y may be continuously increasing or decreasing. I think it is increasing. You can see the function. As x increases, y increases. Okay, there is no turning point. It means maxima or minima does not exist for this function. Y does not become maximum or minimum at any finite value of x. maxima or minima does not exist. That's the conclusion we come to here. So like this, you can find the maximum and minimum values of y when a function is given. Let's look at one or two simple examples in physics. How do we apply this maxima and minima concept in physics? Let's look at example of a body moving in a straight line. A body is moving in a straight line. Its displacement as a function of time is given. We are going to find out at what time displacement becomes maximum. Okay, that's what we are going to find out. I'll write down the example here. Let's answer this question. The question is, a body is moving in a straight line. Its displacement s varies with time according to the equation s is equal to 40t minus 10t square. The first question is, find the instant at which its displacement becomes maximum. And the second question is, find the displacement and distance covered by the body in first 4 seconds. That's what we are trying to find out. So let's answer the first question here. The first question. Displacement becomes maximum at what instant? That is the question. Displacement becomes maximum. So the question already mentions that S becomes maximum at a particular point of time. So you don't have to verify by doing the second derivative whether S is maximum or minimum. Okay, first derivative is enough. S is maximum means ds by dt is equal to 0. S is maximum at what time? That is the question. In other words, the question is ds by dt is equal to 0 at what time? ds by dt means what? Velocity. When s becomes maximum, its first derivative becomes 0 or velocity becomes 0. Okay, what it means is the body moves with decreasing velocity. The body moves in a straight line with decreasing velocity. Velocity becomes zero for a moment and it starts coming back. Look at a body thrown up. If you throw a body vertically up, the body goes up with decreasing velocity. Velocity becomes zero at the highest point. Height becomes maximum. Displacement becomes maximum. At maximum displacement or at maximum height, velocity becomes zero only for a moment. Velocity is not constant at zero value. Velocity is changing. So during the process in which it is changing, at an instant its value becomes zero. So when its value becomes zero, displacement is maximum here. So find out velocity or the first derivative of displacement with respect to time. When you find this, you will get v is equal to 40 minus 20 into t. This is velocity. Look at velocity. Velocity is negative for t less than 2 seconds. At t is equal to 2 seconds. Velocity is positive for t less than 2 seconds. Velocity is positive for t less than 2 seconds. At t is equal to 2 seconds, velocity is zero. The first derivative of displacement with respect to time becomes zero at 2 seconds. It means at t is equal to 2 seconds, displacement is maximum. Displacement is maximum. For t greater than 2 seconds, you can see that velocity is negative. Look at velocity function here. Look at velocity function here. V is equal to 40 minus 20 into t. For t less than 2 seconds, velocity is positive but decreasing. Find out the second derivative. You will get minus 20. Find out rate of change in velocity. Okay, you will get minus 20. It means second derivative of displacement or first derivative of velocity or rate of change in velocity or acceleration is equal to minus 20. Acceleration is negative. Second derivative is negative. Because acceleration is negative, velocity is decreasing. Velocity is positive but is decreasing and becoming zero at 2 seconds, and it continues to decrease. Negative means it is again magnitude may be increasing but it's going in the opposite direction. So velocity continues to decrease. So the question is to find at what instant displacement becomes maximum. So at t is equal to 2 seconds, velocity is zero. So at t is equal to 2 seconds, displacement is maximum. And the second question, let's try to answer the second question. What is the question here? Find displacement and distance covered by the body in 4 seconds. In 4 seconds, let's find out displacement. In 4 seconds, substitute 4 seconds in this equation. You will get displacement is equal to 40 into 4 minus 10 into 4 square. When you simplify this, you will get 0. So in 4 seconds, displacement becomes 0 means what? For the first 2 seconds, velocity is positive. It's going towards right for 2 seconds. Let's say it started at t is equal to 0. And for 2 seconds, it is going towards right. For 2 seconds, velocity is positive. Positive means velocity is towards right. And for the next 2 seconds, it is coming back. Velocity is negative. For the next 2 seconds, it is coming back. Velocity is negative. So after 4 seconds, the body is again at the starting point. That is why displacement becomes 0. Distance is not 0. So for 2 seconds it has traveled forward, and for the next 2 seconds it has traveled backward. So total displacement is 0, but distance is not equal to 0. So for 2 seconds, let's find out where is the body at 2 seconds. To find the distance, what I'm going to do is I'm going to find out where the body is at 2 seconds. So S is equal to 40 into 2 minus 10 into 2 square. You will get 40 meters. So in first 2 seconds, it is traveling in one direction for 40 meters distance. And in the next 2 seconds, it is traveling 40 meters back. For the first 2 seconds, it travels forward because for the first 2 seconds, velocity is positive. In the next 2 seconds, velocity is negative. It's coming back. So it travels 40 meters forward and 40 meters backward so that the displacement becomes 0 in 4 seconds. It means in 4 seconds, the distance covered is 40 plus 40, 80 meters. So answer to the second question is 80 meters. Well, this is how we can apply the concept of maxima and minima in physics. This is one basic example. I'll give you one more example in physics. All right, look at this example here. A body is moving in a viscous medium. Its velocity varies with time according to this function. Okay, don't worry about alpha and beta. Alpha and beta are constants. Now we need to find out the maximum velocity that it can attain during the motion. We call it terminal velocity. Okay, so velocity increases and becomes maximum. After that, velocity does not change. Okay, so we are going to find out maximum velocity or terminal velocity. So this is velocity as a function of time. How do we find terminal velocity or maximum velocity? You know, when velocity becomes maximum, its first derivative becomes 0. When velocity is maximum, its first derivative, that is acceleration. You know, acceleration is rate of change in velocity. Acceleration becomes 0. So our task is to find out where acceleration becomes 0. At what time acceleration becomes 0? We'll find the time and substitute the time back here to get maximum velocity. Okay, so let's find the derivative of this. It's simple. The function may look complicated. This is I'll write down V alpha by beta minus alpha by beta into e power minus beta into t. So dv by dt, we are finding acceleration or its first velocity's first derivative. If you differentiate alpha by beta, you will get 0. And here alpha by beta is a constant. Differentiating this using a chain rule will give you this. Okay, we did this using chain rule. So dv by dt is equal to alpha. Beta and beta get cancelled. Minus into minus is plus. So this is alpha into e power minus beta t. This is acceleration. This is acceleration. Acceleration is equal to alpha into e power minus beta t. This is what we got. At what time the acceleration becomes 0? Only at infinity. As t tends to infinity, acceleration tends to 0 after a very long time. After dropping this body in a viscous medium, it takes very long time for acceleration to become 0. Acceleration becomes 0 after a long time. So at t is equal to infinity, acceleration becomes 0. At t is equal to infinity, velocity becomes maximum. And that maximum value is not infinity. Maximum velocity is not infinity. Velocity becomes maximum. It is a finite value, but it attains that maximum finite value after very long time. That's what it means. So substitute t is equal to infinity in velocity function. V is equal to alpha by beta into 1 minus e power minus beta t. Substitute it here. You will get maximum velocity. You will get alpha by beta. This is a finite value. Velocity becomes maximum after very long time, and this is the maximum value of velocity. So these are two simple applications of the concept of maxima and minima in physics. In the next class, we will discuss how to draw a graph when a function is given only based on the qualitative behavior. When a function is given, we understand how y changes as x changes qualitatively, and then we draw a graph. So without actually putting data points and joining those data points, that's a cumbersome process. Okay, and how many data points are there between x is equal to 2 and x is equal to 3? There are infinite points, and between those 2 points y may become maximum or minimum. We don't know. So we are going to discuss in the next class how to draw a graph when a function is given just based on the qualitative behavior.